Yes, ma'am.
Okay. Have we finished this slide? Good morning, all of you.
Good morning, ma'am.
Let's start.
Okay,
Start,
ma'am.
beta.
Density. The density of a substance is defined as mass of the substance per unit volume. Density is equal to mass of the substance divided by volume of the substance.
So how do we denote? D is density,
D is equals to
mass is M.
V is volume.
Yes, V is volume. So D is equal to M upon V, isn't it? That's the easiest of way to remember. D is equal to M upon V. This is what we had done in the earlier slide. So this is a sort of revision. We read something more about density, please. Yes, start. Start with it.
Density Density of a substance is one of its characteristic properties. SI unit of density is kilogram per cubic meter or kilogram per
Meter
cubic
cube.
meter
No, it is
cube.
kilogram per meter cube. Read
Meter
like
cube
that.
or
Or
kilogram
kilogram M
per.
meter minus 3. Okay? This is how you have to read it out.
Yes, ma'am.
Yes, yes. The last line.
Cgs unit of density is gram per cubic centimeter or gram per centimeter cube or per centimeter
Centimeter
minus 3.
minus 3. Understood now? So we will not go much in CGS unit. We will always go for SI unit. You know that, right? We usually take SI unit. What is density? This is one of the very basic properties of a substance. The SI unit that we are going to work on is kilogram per meter cube, and that's it. So this is what you have to remember. SI unit is kilogram per meter cube, and CGS unit is gram per centimeter cube. Generally, we do not use CGS unit. We always use SI unit. Is it clear?
Yes, ma'am.
Yes? Fine. So what is density? Mass per unit volume. So this is what you have to remember. M upon V. Is it clear? Is it clear?
Yes, ma'am.
Is it clear? Okay. Same thing in a different manner.
Density.
Read.
Mass per unit volume of an object is called density or mass density. Density is denoted by Greek letter Rho. Means P. Density means
So
P.
how do you write? Rho, like this. Okay, this is how you write rho.
Rho.
Okay,
Density means rho is equals to mass by volume or rho is equals to m upon v.
then
SI unit of density. The SI unit of mass is kilogram and SI unit of volume is cubic meter. Therefore, by substituting the unit of mass and
kilogram per.
volume,
So what it is? Kilogram per meter cube, isn't it?
yes,
Then
so we get Rho is equals to kilogram per meter cube. Therefore, SI unit of density means Rho is kilogram per meter minus 3.
what we did? Look at these two slides. The matter is the same, but the presentation is different. What extra did you learn from this slide?
Rho.
Rho, exactly. So That's the reason that why I'm taking so many varieties of slides for one topic, so that things become very clear to you people. Is it helping you out?
Yes, ma'am.
Okay, fine. So any problem regarding this slide, beta? All of you, ninth standard. Is there any problem in understanding?
No, ma'am. Instagram में चला है कसम.
Okay. Now we come to relative density. Please read, beta.
Relative density. The relative density of a substance is the ratio of its density to that of water. Relative density is equal to density of the substance upon density of water. RD is equals to ds upon dw.
Okay. So you know this density of a substance divided by density. So what reference I'm taking? Density of water I'm taking it as a reference, isn't it? I'm comparing it with density of water. Take any substance and then we compare it with density of water.
The relative density of a substance is also defined as the ratio of the mass of any volume of the substance to the mass of an equal volume of water.
Okay.
Relative density is equal to mass of the substance upon mass of an equal volume of water.
Yes.
Relative density.
Hello. Can you hear me? Hello. Can you hear me? Boys, can you hear me?
Yes.
Hello. Yes, I think there's some network issue with Jishan, I think so. He went off the air. Can anyone begin? Can you hear him? Hello? Can you hear Jishan? Boys? Hello? Hello? If you can hear me, then start reading. Hello?
Ma'am. Yes, ma'am.
Yeah, what happened? What had happened? Yes, please continue.
Yes, ma'am. Relative density, mass of the substance, mass of unequal volume of water. Relative density of a substance expresses the heaviness of the substance is comparison to water, as the
In,
relative
in.
density is the ratio of two similar quantities. It has no units.
Okay. So what it is showing? Heaviness of the substance. What it is showing, beta? Heaviness of the substance and what we are comparing to water. As it has got both the things are similar, it has no units. This much is understandable. Yes, boys, is it understandable? Hello, hello, can you
Yes,
hear me?
ma'am. Yes, ma'am.
Okay, is it understandable?
Yes, ma'am. Ma'am, as the relative density is the ratio of two similar quantities. मैम उसका मतलब क्या?
That means the unit is same.
Okay, ma'am.
Okay, that means it has no units. For example, if I take mass of the substance as kilogram, not kilogram, let's talk it about a liter, for example. Yeah, we'll take kilogram only mass. Even the mass of water will be also in kilogram. So it gets cancelled. So it has no units. You understood now?
Yes, ma'am.
Okay. Yes. Begin.
Relative density for conven- convenience,
Convenience.
convenience,
Convenience.
convenience, the density of water is expressed in
Comparison.
comparison of water. Thus, when density of a substance is expressed in comparison with water, it is called relative density.
What are we comparing? The density of substance to the water, isn't it? So it is called relative density. What is the expression? Please read. Yes.
Therefore, relative density, density of substance, density of water,
You should
relative
say, therefore, just a moment. You should say, therefore, relative density is equal to density of substance divided by density of water. You're not saying all this expression. Why? You don't say equal, you're not saying upon. Don't do that. Because it is in mathematical notation, isn't it? Yes, beta?
yes, ma'am.
Yes. So you have to
Ma'am,
explain everything. Hmm? No, it's okay. You have to explain everything. That's what I'm telling you.
yes, ma'am.
Okay? Okay, beta.
Yes.
Then,
Relative density has no unit because it is the ratio of similar quantity. Particle
application.
application of density. Water is taken as reference uh, pa-
Material.
material because it is easily available at most of the places and it is easy to carry out the measurement related to density in field visit when the relative
Yeah, continue.
when the relative density of a substance is less than 1 it will float in water, otherwise it will sink in water.
Okay, fine. Now we know that relative density has no unit because it is a ratio. Ratio means numerator divided by denominator, isn't it? Yes, ratio is what? Something divided by something. This is called ratio. So what is the practical application of density? We always take water as reference material because it is easily available. And also whenever you are going for some study, you can take that or you can carry it in the field study as well. When relative density is less than 1, remember it. When RD is less than 1, that means the substance will float. Okay, the substance will float. Okay, it has to be less than 1. If it's not, then it will sink in water. If it is more than 1, it will sink in water. Understood? On this basis, we are going to read some fundamental properties of water. First one is Archimedes Principle. Please read.
Archimedes principle
Archi.
Archi-
Archimedes Principle.
Archimedes principle state that when an object is immersed
Immersed.
fully
Immersed.
im- immersed fully or
It is
partially
immersed.
immersed fully or
Partially. Partially.
partially in a liquid, it experiences and it experiences an upward force which is equal to to the weight of liquid displaced by the object.
Didn't we study this earlier? Remember upward thrust. Do you remember now? Buoyancy. Yes or no? Did we read it or not? I talked about upward thrust when you put any object in the water, partially immersed or fully immersed. What happens? The water is also applying a force opposite to it. If I am pushing the object, when you're pushing the object in the water is applying an opposite force like this. If this is the surface of water and I've got an object like this, okay, this is water. So it will apply an upward force. Got it? Which is equal to the weight of the liquid displaced by the object. So this must weight of the water which got displaced will be the weight of the object. You understand? Hello.
Yes, ma'am.
Okay. So these are densities of some common substance. If at all we will be doing numericals, it will be given to you, so you need not worry about it. For example, just due to relative density, see the relative density of cork. It is 0.24. That means it is less than 1. Yes or no? Yes or no? Is
Yes.
0.24 is less than 1. So what will happen? It will float or sink. Cork will float in water or sink in water.
Float.
Yes, yes, exactly. It will float on water because it is less than 1. Similarly, what about this one? 0.8 wood. Say fast.
It also float.
Other one.
Float.
Got it?
Yes.
Yes or no? That's
Yes.
it. That's it. So anything which is what you got as
Which is less
less
than
than 1
one. That is float.
float and which will more than 1 all will sink. You got it?
All will sing.
That's it.
Yes.
All will sink. Any problem?
No.
So just for your information, I had taken the chart. See the
Okay.
Archimedes principle. Yes, read.
Archimedes' principle states that when a body is partially or fully im-
Yes, I told you partially. Again, you are repeating the same thing again.
partially
I told you
or
once.
fully
It should be
partially or fully immersed in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it.
yes. This we have already read. I've already explained. Now let's see the next para, please.
Archimedes' principle has many uses. It is used in designing ships and submarines. Hydrometers used to determine the density of liquid. Electrometer used to determine purity of milk, etc.
Where are we applying this Archimedes principle? What are the applications? See, it has got several uses. First, we use it for making ships, designing ships, and also submarines. Now, do you know what are ships and submarines? Hello. Do you know what are submarines, beta? Do you know ships?
which is goes on underwater.
Which one? Submarine or ship?
Float on water.
Ship float on water and submarine goes deep in water, right?
Yes,
This is what the Archimedes principles are used to make those ships and
submarines.
submarines. Yeah. And we have hydrometers. Hydrometers are used to find out the density of liquids, unknown substances. And there is another machine that is called lactometer to find out how pure the milk is. Is it clear? How pure the milk is. Now look over here. Now this is a balance, spring balance. You got a stone tied to a spring balance. Yes? Hello. And it's got a spout. Can you see the spout?
No.
The spout I'm saying. The outlet. It's called a spout. This one. This is called a spout. This is an outlet, isn't it?
Yes.
Yes, fine. Now you can see the level of water is below the spout. So obviously water does not come out. As soon as this stone gets immersed in the water, the level of water comes up. See, the level of water comes up. Yes. And this water displaced by the stone is this much. So if I measure this much of liquid, I will find out this much of water is displaced by the stone. You got it? Hello. I found the measure.
Yes.
This is the water displaced by the immersed object, that is the stone. So when you put a stone, the water displaced is collected, we measure it, so we can say that this is the water displaced by the object. Any problem? Any problem?
No,
Ninth
ma'am.
standard. What about ninth standard? Ninth standard. Boys, did you understand?
Yes, ma'am.
All of you?
Yes, ma'am.
I'm getting only one answer, beta. What about the rest of you people?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
The same thing. Yes, please read. Can anyone start reading, beta?
When an
Hello?
object is fully or partially immersed in a liquid, it experiences a buoyant, buoyant force,
Buoyant.
buoyant force or upthrust which is equal to weight of the liquid displaced by the object.
That's what we learned just now. When an object is
Mm.
wholly, this was wholly immersed, isn't it? See,
Mm.
this is wholly immersed. See, so the liquid displaced, isn't it? It
Yes.
is wholly immersed. Fine.
Mm.
So what happens? There is a buoyant force or upthrust. Now that becomes equal to the weight of the liquid displaced. Yes or no?
Yes.
This is what we learned just now. Okay. So what is buoyant force?
Buoyant force acting an object, weight of liquid displaced
It's
by
equal
it.
to beta. You are not reading things very,
Okay.
you have to be very particular about it.
Buoyant
It's
force
equal
or
to.
upthrust acting an object is equal to weight of liquid displaced by it.
You understood?
Yes.
Yes.
Application of Archimedes principle. Archimedes principle is used in determining the relative density of a substance. Second, the hydrometer used to determining the density of liquids are based on Archimedes principle. Third, the lactometer used to determining the purity of milk are based on Archimedes principle. Fourth, Archimedes principle is used in designing ships and submarines.
Anything extra you got in this slide? Or is it the same? You read both the slides. Did you find any difference in this slide? Any particularity? Yes, say something. Hello.
No, ma'am.
It's the same, isn't it? But the expression was different. The
Yes.
matter was same. What that is what I'm asking you. The matter was same. We already have learnt it in the earlier slide, but the presentation was different. This is what I want to show you. That the answers what I am giving is the same, but you can have your own presentation. Do you understand what I'm saying? Got it?
Yes, ma'am. Yes.
Fine. Okay. Let's read. Please read. Hello, please read.
Yes, ma'am. Application of Archimedes principle. When the weight of displaced liquid by an object is greater than the weight of object, the object will float in liquid, and when the weight of liquid will be smaller than that of the weight of the object will sink in liquid.
So, what did
Eh,
you understand? That the displaced liquid we will measure. We will find the weight. So, if it is more than the weight of the object, what will happen? It will float. The object will float. And when the weight of liquid will be smaller, which the weight of liquid displaced will be smaller than the weight of the object, obviously the object will sink. Is it clear?
yes.
Clear, beta? Okay. First, yes,
In
read.
submarines. In submarines, there is a tank which can be filled or em-
Emptied.
emptied, emptied as per requirement. It is called buoyancy tank. When submarines have to go inside the water, the buoyancy tank is filled with water so that the weight of submarines would be become more than the weight of water displaced by it. And when submarines have to come over the surface of water, the buoyancy tank is emptied and water is replaced by air. In the condition, the weight of water displaced by submarines will become more than the weight of submarines, and submarines become over the surface of water.
Understood how it is going under the water and how it is coming above the water. It is only due to the buoyancy tank. Got my point? So, what is making submarines go under the water and come on the surface of water? It's only due to buoyancy tank. So, what happens? This buoyancy tank can be filled or
When
emptied. Yes,
yes, when filled that when submarines goes under the water, the
yes,
tank is filled with water.
filled. Exactly. So, it becomes heavy.
Yes, and
Yes,
so
so weight
the
of the submarine
submarine
becomes
is
heavy. So, the
when
submarines
they
go inside the water.
and
And
when
when
they
they want
come
to come
out,
up, yes, what they
they
do?
their
They
water
empty.
emptied.
Yes, 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 yes. Explain better, no problem.
वो टैंक को एम्प्टी कर देते हैं ताकि वो उसका जो वेट
Oh,
है वो
you
सबमरीन का
just
वेट
just a moment. Just a moment. You were going good in English, better. Don't worry if you go wrong. Don't shift to a Hindi, please.
ओके
Continue in
मैम
English. I will help you. Huh? I will help you better.
ओके मैम
Okay.
they emptied
Say.
the tank so tank
So what
submarines
happens?
come out.
Okay. So water is replaced when the tank becomes empty. So in the tank, what is there? Air. What will be in the tank then? Air. If water goes out of the tank, what is there in the tank then? It is air, and air makes it light, isn't it, Vita? Hello?
And
So it
okay
becomes
मैम
very lightweight. So it comes up the surface of the water. All of you understood, Vita? Ninth standard?
yes मैम
Boys? All of you? Rest of them are not giving any response. That's why I have to, address them as ninth standard. Because you are answering, rest of them are not.
mm,
Yes, boys, finally. Did you understand how submarines go under the water and they come on the surface? Hello? Can you hear me?
yes मैम I'm
Okay, okay. Now we come to the next example. Please.
air, air balloons air balloons to raise the air balloon in air. The air inside the balloon is heated. Air expand air expands because of heat and become lighter. Thus the balloon gets an upward
Air
thrust.
expands because of heat, better. Read it again.
Expand, air expands because of heat and
Air
become
expands
lighter.
because of heat.
Expands
Hmm.
because of heat and becomes.
So what happens?
Thus, the balloon gets an upward thrust from the surrounding air and rises up.
Understood? Can you explain
Yes.
this? You know what is the air balloon? We use it for weather forecasting.
In
Air
bu-
balloon. I think in 8th
in
standard I've
balloon,
taught you.
the
Air
air
balloon
is
for weather
which
forecasting.
air is heated, so balloon becomes lighter, and then balloon gets upward
Exactly.
and surrounding air and rises up.
Yes. It goes upward. It rises up in the air. Yes, because warm air, heated air is lighter than the normal air.
Mm.
So when it is light, so it goes up in the air. Simple. Okay, so it gets the upward thrust from the surrounding air and it rises up. Yes. Where are we using this hot air balloon beta?
What, ma'am?
The meteorological department. That is, where are these hot air balloons used? For weather forecasting. Got it?
Yes.
Yes. Okay. Now we come to ships.
Ships.
Explain.
A ship, a
Read
ship
beta.
is much heavier than water, yet it floats on water. This happens because of unique shape of the ship. Because of it is a shape, the volume of the ship is larger compared to its weight. Due to this, water displaced by the ship provides a proper upward thrust to the ship and the ship floats on water.
Okay. So can you explain? Can you explain?
Yes, ma'am. The ship is much heavier than water. Then it is float on water. This happens because of ship's unique shape. And because this is
What is the shape?
shape of
What is the unique shape?
volume of ship
It's like this, isn't it?
is larger
What is the
compared
unique
to
shape?
its
This is called as
ship
streamlined beta.
stream
Streamlined. I taught you everything. Streamlined. And that's the
streamlined.
reason the boat, the ship, and the birds. Remember? Birds,
Yes,
fish. Yes, remember?
yes,
They can fly and they can swim and they can float because of the
mm,
unique shape, and that shape is streamlined body. What it is,
yeah.
beta?
Streamlined body.
Streamlined body.
Yes,
So it is thick from here and narrow
mm,
from both the sides, isn't it? Here also
yes,
narrow and here also narrow. Okay.
yes.
Then,
Due to this, water displaced by the ships provide a proper upper thrust, and the ships floats on water.
yeah. So water displaced. The water which is displaced by the ship,
Mm,
obviously you get a
proper upper
upward
thrust.
thrust, the buoyancy,
Mm,
because of the volume, which
volume
is
of
larger.
ship larger than water weight.
Volume of water displaced is more than the weight of the ship. You understood?
Yes.
Then only it can float. Otherwise, it will sink, isn't it?
Yes.
Isn't it? Yeah. So water displaced is giving a buoyancy to the ship, and the ship remains floating on water. Hope all of you have understood this.
Yes.
These words, all of you, do you find any difficulty in understanding? Rest of the boys? Hello?
Yes, ma'am.
Yeah. Is there any problem in
No, ma'am.
understanding Archimedes principle?
No, ma'am.
Okay.
No.
So we come to a close of this chapter.
Mm,
This was the last slide. It was a big chapter rather, but a very important chapter. Now we come to a close. I will be sending you the textual questions. In text questions I have already done, but in follow up I have not got. I'm sorry to say I have still not received any information regarding your completion of homework, and you really it's very disappointing. I should rather say. In text questions were given you earlier. In weeks time, at least in weeks time, not at least, at most in weeks time, it should be over. Have you completed the in-text questions? Ninth standard? Hello? Of this chapter, I've already given you. Remember? Why no answer? Boys, can you hear me? Hello, boys, can you hear me? Hello? Hello, can you hear me? Boys? Hello? Hello?
Yes, ma'am.
Boys, can you hear me? Yes,
Yes,
what
ma'am.
happened? Absolute
Nothing,
silence from you people.
nothing,
I
ma'am.
just
But
asked you whether you have, yeah,
I think,
whether
ma'am,
you
the
have finished
lecture
it.
is over. That's why everyone
What
has
is
left.
next?
10:50.
Only you are there?
Yeah, ma'am.
Yeah, doesn't matter. You are very particular, I think so. This class, because in 7th I'm there till 10:20.
Yes, ma'am.
That's what I said. In 7th standard,
But
everybody is present till 10:20.
Yes, my home network was gone. Wi-Fi. So,
Okay, okay. Anyways, please beep